What happens when the oceans stop moving? At first, the idea sounds surprisingly peaceful. No more powerful currents. No more rough seas. No more storms fed by warm ocean water moving across the planet. The oceans become calm, still, silent. Many people imagine a world with gentler weather, safer coastlines, more predictable seas. Ships continue crossing the oceans. Fish continue swimming. The tides still rise and fall. After all, the water remains. The oceans do not disappear. They simply stop moving. And if the water is still there, how much could really change? Perhaps very little. Perhaps the oceans become quieter. Perhaps life simply adapts. But that's not even the most dangerous part. The real danger is that the oceans are not merely bodies of water. They are circulation systems. Planetary circulation systems. The oceans move heat, nutrients, oxygen, carbon, energy, every second. Without that movement, Earth does not lose its oceans. It loses one of its most important life support systems. To understand why, we first need to understand what ocean circulation actually does. At this moment, enormous currents are moving through every major ocean basin. Some currents operate near the surface. Others travel thousands of meters below. Together they form a global network sometimes called the thermohaline circulation, a planetary conveyor belt driven by differences in temperature and salinity. Cold water sinks. Warm water rises. Dense water moves. Lighter water follows. The process never truly stops. It has been operating for millions of years. Most people never notice it. Yet civilization quietly depends upon it. The Gulf Stream alone transports enormous quantities of heat across the Atlantic Ocean. Without it, large portions of Europe would experience dramatically different climates. Ocean circulation helps regulate rainfall. It helps regulate temperatures. It helps regulate ecosystems. It even helps regulate the atmosphere itself. The oceans and the atmosphere are partners. Each continuously influences the other. Now imagine that movement suddenly ends. Not slows. Not weakens. Stops. The surface appears calm. But beneath the calm, the planet begins changing immediately. The first effects emerge in climate. Not because the oceans disappear. Because heat stops moving. Near the equator, the oceans constantly absorb tremendous amounts of solar energy. Today, currents distribute much of that energy toward higher latitudes. Without circulation, the redistribution ends. Tropical regions begin retaining more heat. Polar regions begin receiving less. The climate system starts separating into extremes. Some places become hotter. Others become colder. The difference between regions grows larger every year. At first, the changes seem subtle. Weather forecasts become less reliable. Seasonal patterns begin drifting. Rainfall shifts. Growing conditions become less predictable. Then the effects become harder to ignore. Europe begins cooling. Parts of northern North America begin cooling. Meanwhile, tropical oceans become increasingly warm. Heat accumulates where it can no longer escape efficiently. The planet is still receiving energy from the sun. But it is no longer distributing that energy effectively. Imagine a human body where blood stops circulating. The body still contains blood, but the system no longer works. The oceans face a similar problem. Then comes oxygen. Most people think of oxygen as something produced by forests. But the oceans generate a tremendous share of the oxygen entering Earth's atmosphere. Microscopic organisms called phytoplankton perform much of this work. They thrive because ocean circulation continuously delivers nutrients from deeper waters. When currents stop, nutrient transport begins failing. The surface ocean slowly becomes nutrient poor. Phytoplankton populations begin declining. Not immediately, but steadily. And because phytoplankton sit near the foundation of marine food webs, their decline spreads outward. Small organisms lose food. Fish lose food. Predators lose prey. Entire ecosystems begin weakening. The damage phase begins quietly. The open ocean becomes increasingly stratified. Surface water remains near the surface. Deep water remains below. The natural mixing process disappears. Oxygen levels begin falling in deeper waters. Marine organisms that rely on oxygen-rich environments begin struggling. Dead zones expand. Regions where oxygen becomes too scarce to support complex life. At first, these zones appear in isolated areas. Then they begin growing. Marine ecosystems start fragmenting. Species migrate. Populations shrink. Food chains weaken. The oceans become biologically poorer. Then the fishing industry begins noticing. Fish stocks become less predictable. Traditional fishing grounds decline. Harvests fall. Prices rise. Coastal communities experience economic pressure. Entire regions dependent upon marine resources begin adapting to scarcity. But scarcity is only one part of the problem, because the oceans also absorb enormous amounts of carbon dioxide. They act as one of Earth's largest carbon sinks. Ocean circulation helps transport carbon into deeper waters. When circulation stops, that process weakens. More carbon remains in the atmosphere. Climate regulation becomes less stable. The atmosphere begins carrying a larger burden. And then the escalation begins. Ocean ecosystems lose productivity. Fish populations decline further. Food security weakens. Coastal economies contract. Carbon accumulation increases. Climate extremes become more common. Rainfall patterns become less reliable. Agricultural planning becomes more difficult. Water management becomes more difficult. Energy systems face growing uncertainty. Insurance costs rise. Migration increases. Governments face mounting pressure. International cooperation becomes more difficult. Supply chains experience disruption. Food prices continue climbing. Regions already vulnerable to drought become even more vulnerable. Regions dependent upon stable rainfall begin experiencing instability. Freshwater resources come under stress. Hydroelectric systems face unpredictable conditions. Infrastructure designed around historical climate patterns becomes increasingly outdated. The world becomes harder to predict. And civilization depends heavily on predictability. Then the spread begins. The effects do not appear everywhere equally. The Atlantic experiences major disruption first. Other ocean basins respond differently. Certain regions cool. Others warm dramatically. Some coastlines become wetter. Others become drier. Storm behavior changes. Monsoon systems shift. Ocean-dependent weather patterns begin reorganizing. The atmosphere starts searching for a new balance. But finding that balance takes time. Years pass. Marine biodiversity continues declining. Coral reef systems struggle under changing conditions. Some fisheries collapse. Others migrate toward unfamiliar regions. Entire industries begin relocating. Coastal economies evolve or disappear. Trade routes adapt. Agricultural zones shift. The geography of opportunity begins changing. Decades pass. The oceans remain. Still vast. Still beautiful. But increasingly different. Large areas become less productive. Nutrient cycles operate less efficiently. The biological engine of the sea loses momentum. Species once abundant become rare. Some vanish entirely. Others dominate newly altered ecosystems. The balance changes. Not through violence. Through stagnation. And stagnation is one of the most dangerous conditions in nature. Because life depends on movement. Blood moves. Air moves. Water moves. Nutrients move. Energy moves. The systems that sustain life are rarely static. They are dynamic. Continuous. Flowing. The oceans are no exception. For millions of years, they have connected every continent through invisible rivers of water moving beneath the surface. Most people never see them. Most people never think about them. Yet those currents quietly influence harvests, weather, food supplies, economies, ecosystems, and daily life. The ocean appears calm from above. But beneath that calm exists motion. A vast hidden machinery operating across the entire planet. And perhaps that is the most unsettling realization of all. The systems that keep Earth stable are often invisible. Not because they are small, but because they are constant. The currents beneath the oceans, the winds above the oceans, the cycles moving nutrients through the sea. They continue every day without asking for attention. And because they are always there, we assume they always will be. Until one of them stops. And humanity discovers that what looked like still water was actually one of the most important engines on Earth. If you enjoyed this journey into the hidden systems that keep our planet alive, please like, share and subscribe to the channel. What did you learn for the first time by watching this video? Let us know in the comments. Thank you for watching. Stay curious.